So let's talk about fermentation, which happens in anaerobic conditions. So we have two kinds of fermentation. There is lactic acid fermentation and alcoholic fermentation. And they both serve the same purpose, but their reactions are a little different. So let's go ahead and talk about why this would happen. So normally, cellular respiration starts with glucose in the cytoplasm, and it undergoes glycolysis that produces or ends with two pyruvates. Now, in the process of glycolysis, we do make two ATPs, a net gain of two ATPs. So in glycolysis, it is an energy-producing pathway. However, it only makes two compared to aerobic respiration in the mitochondria with the electron transport chain and the Krebs cycle making anywhere from 30 to 36 ATP, which is a lot more. So another thing, though, that's required for glycolysis is NAD+. NAD+ is an electron carrier that is going to gain electrons during glycolysis, and the electron carrier will become reduced. So this is an important step that's required for glycolysis to continue. So normally, the electron carrier in aerobic conditions would head over to the electron transport chain where it'll basically be oxidized. It's going to donate its electron and its hydrogen electrons into the ETC. And now, though, that electron carrier can be reused and glycolysis and the Krebs cycle can continue. So we absolutely need NAD+ for glycolysis to occur. Now, what happens, though, when there isn't any oxygen available, at least temporarily, in the mitochondria, right? Let's say oxygen hasn't diffused into the cell quick enough, and so temporarily the cell is running only on glycolysis, and it's getting that 2 ATP, but that's all the ATP it's making in those moments. Well, you really want to make sure that NAD+ does not run out. If NAD+ runs out, then there'll be all energy-producing pathways will stop. So, in simply glycolysis, pyruvate is the end product. But when there's not any oxygen, and we don't have aerobic respiration, pyruvate isn't going to enter the mitochondria. Pyruvate is now like a waste product at the end of glycolysis. And at this point, it will actually stay within the cytoplasm. So keep in mind that during glycolysis, the electron carrier picked up electrons and hydrogens. It was reduced. Now, in order to continue glycolysis only, we need to oxidize that electron carrier. We need to let the electrons and hydrogens off of the electron carrier, putting it back into NAD+, so that we can at least continue just glycolysis. So where do we have to put the electrons and the hydrogen? Pyruvates. So the electrons and hydrogens are going to be taken off of the electron carrier and added to pyruvate. Now, this oxidizes the electron carrier. NADH is now back to NAD+, and that's really what we were focusing on. That's really what we need to happen so glycolysis can continue. Now, in that process, though, of pyruvate gaining electrons and hydrogens, that causes pyruvate, the chemical reaction, is pyruvate is now converted or turned into lactate or lactic acid. So, in the process of lactic acid fermentation, glycolysis occurs in the cytoplasm, and in anaerobic conditions, there is no electron transport chain. And therefore, there's nothing to oxidize or take the electrons from the electron carriers. So therefore, we need to put the electrons onto something, and in this case, they get added to pyruvate. And that converts pyruvate into lactate, or converts pyruvic acid into lactic acid. And now, though, we did regenerate, or we did recycle the electron carrier back to NAD+, so glycolysis can continue. Now, in that pyruvate, though, there was a lot of potential energy. So this lactate, or lactic acid, still has the 3 carbons. It still has potential energy. So your liver will actually take that lactic acid and turn it back into pyruvate for us. So when conditions are back to aerobic, we can still harvest the energy from it. Now, the second type of fermentation is alcoholic fermentation. And it's the same exact why, like the same exact reason. In anaerobic conditions, we need to make sure that we have the electron carrier being regenerated or recycled. So we have glycolysis starting with glucose, ending with pyruvates, making 2 ATP. And so during glycolysis, the electron carrier is going to pick up 2 electrons and a hydrogen, which we call reduced. Now, again, without the electron transport chain, we need to somehow put these electrons and hydrogen somewhere. We need to oxidize this electron carrier. So again, though, in alcoholic fermentation, the electrons and the hydrogen are added to pyruvate. Now, this will allow NAD+ to reform, and we can continue glycolysis. This, though, what happens in this type of fermentation, the pyruvate, when it gains the electrons and the hydrogen, actually, there's going to be multiple steps here. One of the things that happens is a carbon dioxide is actually released as a waste product. So the carbon dioxide gas will be formed. And then we get acetaldehyde, but then the acetaldehyde is going to be converted into ethanol. So ethanol is alcohol, and so here we have alcoholic fermentation. This is the process that produces like beer and wine. So alcoholic fermentation occurs in yeast, and yeast, like brewer's yeast, is what they would use in a brewery. And so basically it'd start with like malt, which is a maltose, which is a disaccharide. And then the yeast would go through glycolysis and then ferment those sugars, producing carbon dioxide gas and alcohol. Or ethanol is the name of the alcohol. And yeast will also do this process when like bread rises. You mix yeast, baker's yeast, in with the dough and the sugar and the flour. And so when the yeast are undergoing fermentation, they produce carbon dioxide gas, and that's what causes the bread to rise before you bake it. And then when you bake it in the oven, the alcohol burns off. And so that you're not eating alcohol when you eat bread. But the air pockets, if you ever cut open bread and there's like holes in the bread, that's from pockets of carbon dioxide gas. Okay, so that was alcoholic fermentation. Now animals, we do lactic acid fermentation. And some bacteria will do lactic acid fermentation, like the bacteria that live inside of us do lactic acid fermentation. And then yeast, and then some other bacteria will do alcoholic fermentation. All right. Good job.